Let's say we have some very simple struct and would like to compare it using the comparison operators. To do so, we would have to implement the equals operator, smaller than and greater than operators, smaller than equals and greater than equals operators, and prior to C++20, the not equals operator. However, C++20 is clever enough to auto-generate this one by inverting the result of the equals operator. To avoid duplicate code, it is considered good practice to just implement one of these operators and to use it to implement all the others. However, we're still left with a bunch of boilerplate code for just a fairly simple comparison. C++20 addresses this issue by introducing the new three-way comparison operator, also known as a spaceship operator because of its shape. Before we implement it ourselves, let's look at an example of this operator in use. For now, don't worry about the return type yet, we'll look more into this later. Given numbers a and b, the spaceship operator will result in a value smaller than 0 if a is smaller than b, 0 if they're both equal, and greater than 0 if a is greater than b. While we can indeed compare them to 0, the standard library provides some functions to check the result of the spaceship operator. Is equal and is not equal, is less than and is greater than, and finally is less than equal and is greater than equal. Let's go back to our SimpleStruct now. To use the spaceship operator, we remove the existing comparison operators, except for the equals operator, and replace them with the spaceship operator. This operator will simply return the result of the spaceship operator on the values of the compared simple structs. Our equals operator will use the operator we just created to avoid code duplication. Now we're capable of using all the operators without the code overhead of implementing all of them separately. One small note, it's also possible to make a default spaceship operator. When we do this, the equals operator is also implicitly defaulted. However, the exact behavior of this default spaceship operator is outside of the scope of this video. Let's take a closer look at the return type of the spaceship operator. There are three possible types: a strong ordering, weak ordering, or partial ordering. A strong ordering implies the following two things. First, the values are comparable. This means that given the operators smaller than, equals, and greater than, exactly one must be true and the others must be false. And second, it implies that comparison salient state of equivalent values is indistinguishable. But what exactly does comparison salient state mean? Well, comparison salient state is state that is relevant for a comparison. To explain this, let's look at a string. A string has a size, capacity, and pointer to an array of characters. However, to compare strings, only the size and content of the array of characters are relevant. These would be considered comparison salient. The capacity and pointer to the array of characters are not considered comparison salient. This means that a string comparison will return a strong ordering despite being able to distinguish between equal strings by looking at the internal C string. Next up, let's take a look at the weak ordering. A weak ordering, just like a strong ordering, implies that the values are comparable, meaning that exactly one of these comparison operators must be true. However, unlike the strong ordering, equivalent values can have distinguishable comparison salient state. Consider this struct called fraction, with a numerator and a denominator. Both of these values are relevant to compare, so they would both be considered comparison salient state. However, we still want the fractions 1/3 and 2/6 to be considered equal. This behavior is exactly what a weak ordering is for. The exact implementation of this operator is not important right now, but can be found in the Git repo in the description. As you can see here, the comparison behaves as expected, despite the internal data being different. The last type of ordering is the partial ordering. Just like the weak ordering, comparison salient state of equivalent values can be distinguishable. However, unlike the weak ordering and strong ordering, the data does not always have to be comparable. This means that the operators smaller than, equals, and greater than could all return false at the same time. A great example of this is a floating point number. All comparisons with a value of not a number will return false, even when compared with another not a number value. Let's quickly summarize all the concepts seen so far. The C++20 three-way comparison also known as the Spaceship Operator, can help reduce boilerplate code by replacing most comparison operators. It can return a strong ordering, weak ordering, or partial ordering depending on our needs. We usually don't look at this return value directly, as the other operators will get automatically generated if the Spaceship Operator is present. However, if we do decide to check out this return value manually, we can do so by comparing it to 0 or by using some standard library functions. All the code and tests can be found on GitHub via the link in the description. If you enjoyed the video, please leave a like and consider subscribing. Any feedback in the comments down below is also greatly appreciated. Thanks for watching, until next time.